Alright, so I like to calculate the margin of error separately from the mean. So mu belongs to 77.2 minus 2.23 times 13.3 divided by square root of 11 is 8.94. 8.94, comma. And then it'll be 77.2 plus 8.94. Now I get this question a lot. How many decimal places do you use? My habit is to go one more decimal place from the sample mean. For better or for worse, that's what I like to do. It gives a little more information, a little more fine-tuning. But in practice, it's what accuracy are you looking for? That's up to you. All right, so the margin of error in our sample is 8.94. So when we add and subtract these, and I want to write this out. The 95% confidence interval is mu belongs to, and get my calculator here, 77.2 minus 8.94 is 68.26, and then same calculation but adding 8.94 gives us 86.14. Alright, so that's our confidence interval. Now I'm going to write out an interpretation of this confidence interval, and as I expected, if you take a test from me, I'm going to ask you to explain what these things mean. So, and I wish I had a large board here and someone to operate the camera, but I'm just going to have to make room on what I've got. I'm filming from my one of my spare bedrooms, which I call the scriptorium. Scriptorium is Latin for the writing room. This is where I do a lot of my work in writing. And this is a 4 foot by 6 foot board. Is that 6 foot? No, I think it's 3 feet by 4 feet. 3 foot by 4 foot whiteboard screwed onto one wall. All right, so anyway, this is what it means. There is a 95% probability that the population mean for final exams in Math 160 is between 68.26 and 86.14. There we go. So here's how I interpret it. And let's spend a little time talking about that. Okay, so we said, all right, we took a sample. It's a pretty small sample. 11 is a small sample. So would you expect to get a lot of great information out of a small sample of 11? No. No. Larger samples will give you better, more focused information. So we said, all right, well, the class scored 77.2 on average. What would a typical Math 160 class? If this is a typical Math 160 course, what would they score normally as far as the population mean? So we're trying to estimate the population mean from this one sample. And we say, well, we're 95% sure that the population mean is going to range between 68.26 and 86.14. All right, so that's an estimation. That's a confidence interval. And now there is a 5% chance that we're wrong. So one time out of 20, if We could be wrong. Maybe Math 160 students on average score below 68.26, or maybe they score above 86.14. All right. Now, and I'm going to do this again with another problem later down the road, but I want to get you really thinking about what is a confidence interval? What can you do to improve it? What would be an improvement? This is not a very close estimate. You might think there's a lot of slop in this value. I mean, it's the sample mean plus or minus 8 point something. That's a lot of slop. Now, what if I had 100 students or 1,000 students? What would happen to this confidence interval? Well, I've erased the formula, but if you study the formula, because you're dividing by the square root of n, a larger sample size will make the margin of error smaller. And so a larger sample will shrink this confidence interval down. It'll provide a more focused estimate. Right now I have a very unfocused estimate. But a large sample size will bring it closer together. And that would be good, because then we got more accuracy. We can say, well, look, I'm 95% sure it's between these two values. You know, we could get that from a larger sample. So larger sample gives you smaller confidence intervals, which is good. More focused result. And so, because, you know, you might think, well, this doesn't tell me much. Well, if that's the case, then I need a bigger sample, don't I? Okay, it's only so much you can do with 11 pieces of data. Now, here's another consideration. We talked about 95% confidence. That means I'm going to be wrong 5% of the time. Well, what if I wanted to be wrong 2% of the time and be 98% confident? What would happen to our confidence interval? Well, recall on the bell curve, 95% was here. If I went to 98%, that would spread it out even farther. It would make for a wider confidence interval. It only makes sense because if you're going to be 98% confidence and I have only a 2% chance of error, then I need to expand this. I need to have a wider range of values in order to have less chance of making an error, don't I? And if I cut my confidence down to say 90% or 80%, what's going to happen? Well, 80% confidence would be a shorter confidence interval. But now there's a 20% chance that I'm wrong. So there, by decreasing confidence level, I have a smaller confidence interval, and in that case it's not good. In that case, a smaller confidence interval is not good because there's a greater chance I've made an error. If I increase my confidence level, I have a wider confidence interval, and that's not good because it may be too broad to be useful, to mean anything as an estimate. So anyway, I'm going to talk about that again later on with another example, because I really want you to get that point and grasp all that. You should know I've taught this course a lot, and people who are very good at math pick this up rather quickly. That's not to put anybody down who does not pick up math very quickly. You know, we're all built differently. It's okay, because I know some of these concepts can be pretty difficult for actually the majority of our students in Math 160. So it takes a while to kind of soak it all up and take it in. So you'll see me, repeating myself in ways because I'm used to teaching this course. I know how people learn it. So anyway, a little bit of repetition on my part. All right, well, let me do another example very similar to this. I'll take this from the book.